Hi, I'm Jim W6LG, or YouTube Elmer with Ham Radio Basics. Welcome to my radio room slash studio here in Rockland, California. A friend of mine has an A-11A amplifier from Ameritron, and I had some difficulty tuning it up and understanding the instructions. So I got the PDF online, and I'm going to look at it now. We'll look at it together. The amplifier that he has looks a lot like this one, and I think this is the 3-tube amp. Price point's around $1,000, and it gets I think it's probably 600 to 800 watts of output, somewhere in that neighborhood. Let's just say it's 800 watts of output. So if you go from 100 to 200, that's 3 dB. 200 to 400 is 3 dB. 400 to 800 is 3 dB. So that's 9 dB total, which would be about an S-unit and a half for around $1,000. So that's pretty reasonable. The instruction book, which, as I said, is downloaded as a PDF. I've scanned ahead to the page on tune-up. And let's go through that real quick. There may be, I don't know why my friend is finding it confusing, but let's take a look at it. It on the first page talks about tuning up. I did find this in the CW mode, and then it goes into SSB. Now, likely most of us are going to be using this amplifier on SSB. Sure, CW will happen, but likely most of the time it's going to be on SSB. And let's look at this. It says tune up the exciter. Okay, they use the phrase exciter. Tune up the exciter and amplifier. Generally, we have transceivers, not exciters. As described in the tune-up section, which I think is a prior page, switch the exciter to SSB. Normal range of meter readings on SSB are between 20 and 50% of the CW carrier readings. This is due to the different peak to average power ratios in the operator's speech waveform. The only true way to measure peak power output is with a good peak reading wattmeter or monitor scope. A whistle should produce the same values obtained on CW. Not necessarily. In fact, I would hope not. Any effort to run more than these values, well, what are these values? Oh, the CW values? Okay. Will produce splatter and distortion, which I just did in a video. Okay, as far as 20 to 50% of the CW readings, that shouldn't happen. If you're at 50% of it, what they're saying is if you go from CW to SSB, and let's say your peak plate current is an amp. I don't know what it should be on this amplifier, but we'll find out. Let's say the peak plate current for CW was 1 amp. They're saying you could have 200 to 500 milliamps of plate current show when you're speaking into the microphone and transmitting an SSB. I would suggest that if you're at 50%, that's way too high. You will not only produce splatter, but these are A-11As and they're not very forgiving. So I would suggest 20 to 25% at the very most. So here's the section on tune-up. And in this graphic, they're not saying what the knobs are for, but this is the load control on the left, and this is the plate control on the right. Why they don't use an actual picture of the front of the amplifier, I don't know. So meter IP, which would be meter plate current. It would be easier if it said plate current. High voltage. This is the transmit. XMT means transmit or operate. or standby. So this puts the amplifier into transmit and the LED lights up. This is the on and off switch. This meter is the plate current and plate voltage meter, and this one is the grid current. The reason for the separate grid current meter is it's really important that you don't exceed whatever the rated grid current is for the tubes that are in the amplifier. Okay, this amplifier, let's go up to the schematic. Maybe it's down here. This amplifier has 4 tubes. And I'm going to look and see what the tubes are. I want to make sure I've got the right amplifier here. Yeah, this amplifier has 5 72Bs. So there are 4, and that's a fairly rugged tube. 572B is a beefy version of an 811A. All right, let's go through this real quick. It says set the 811, okay, HG probably means they've substituted the 811As for 572Bs. Describes the switches, line cord, power on switch. Okay, I stopped because there's already a mistake, and I've just a few seconds into this. With the amplifier, XTM switch still on standby. Well, it's an XMT switch, and again, it might be simpler if it said transmit, but okay, so there's a misprint right there. Still in standby, check the VSWR of the antenna. I would suggest to you that before you even turn the thing on, you check the SWR of the antenna with your transceiver, maybe an external SWR meter from the transceiver. The SWR, they want it to be less than 2 to 1. It tells me the tank circuit in the pi network in the amplifier, the tank circuit, is designed to have an excursion of impedances that would allow up to 2 to 1 SWR and not beyond that. It also, there's a little misprint here, right there. The transceiver's internal tuner cannot, that's incorrect, it's one word, cannot be used to tune the antenna during the use of an amplifier. Well, okay, I understand what they're saying. The tuner comes before the amplifier, so it has no impact on the amplifier. Okay, here they're talking about transceiver. Here they're talking about exciter. So turn the exciter drive fully down after tuning. Well, the likelihood of you having an exciter that you tune is fairly small. It's possible, but most of us are going to have transceivers which are no tune. So if you had a transceiver that had a plate and load control and a band switch on the front, then you would tune it up before you tried to transmit into the amplifier, of course. Place the amplifier band switch on the same band as the exciter. Place the plate control in the dial range for the band selected and the load control as indicated. Is that confusing or not? Place the amplifier band switch on the same band as the exciter. Okay, so you put the transceiver, let's say, on 20 meters and the amplifier on 20 meters. The plate control and the dial range for the band selected and the load control, it should say and the load control then as in the dial range selected, and that's up here. And since they've put these together, it is pretty confusing. It'd be nice if this was one long column, because this is separate from this. So let's say we're 20 meters. Okay, so we come down here. Here's 14 megahertz. The load would be at 3. The plate would be at 9. And this is the load control, and this is the plate control. Okay, we already covered that misprint. So what you're going to do is you're going to put the plate in load control as indicate in that like spreadsheet thing up here. Okay, so far it's been pretty confusing. Key the exciter. All right, put the transceiver into transmit mode. Transmit XMT LED. I don't know why that's in parentheses. It shouldn't be, and it doesn't need to be bold, but it can be. The transmit, and why transmit's capitalized, I don't know. The transmit XMT LED should light. All right, the XMT LED will light. Observe the plate current on the 750 milliamp scale. It should be 75 milliamps. Okay, so here's the idling current. Here's the current that the amplifier will indicate if you just put it in transmit and there's no drive. Having said that, if you had the amplifier and you shorted out the phono jack in the back with nothing connected to it, then there would be 75 mils of idling current, 75 mils of current with no drive. If it's anything different than that, substantially different, then something's wrong. Note in bold, the no drive current will vary up to 25%. Okay, they're talking about that 70. They don't say what that is. Down here, they don't call us no drive current, but that's what they're talking about. So up here, the no drive current, which is 75 milliamps, will vary up to 25% due to component and line voltage tolerances. So as the line voltage varies, the plate voltage would vary, because if the plate voltage is lower, it would have a lower idling current. During tune-up, limit key, okay, it's capitalized with a K, I don't know why, to 7 seconds. What they're saying is the keying time or key down time, transmit time, keep it less than 7 seconds. This will keep the tubes from overheating. Well, how about keeping them from being damaged for sure? I don't know why this is stuck out here. Again, this probably should be here. This amplifier is equipped, I think is what they mean. It should be a D in there. Equipped with that should be an electron grid overload circuit. When there's an article missing. When the peak grid current reaches 190 milliamps, the amplifier will go into standby. Misspelled. The D is missing. That's totally wrong. And the red XMIT LED will not light. Okay, here's another misspell. They have it on the front panel, and they've called it XMT and XTM, and now they've got it XMIT. Okay, folks, which is it? The amplifier will go to standby, and the red XMT LED will not light. Okay, the thing won't transmit what they're saying. It'll go into bypass mode. Reset by toggling the standby operate switch. Okay, now we're calling it a transceiver instead of an exciter. Place the transceiver in the CW, FM, or RTTY mode and apply only enough drive to indicate a grid current of 100 milliamps or an IP plate current of no more than 450 milliamps. I think that's misguided. Tune the plate control for maximum power output. It is normal for the plate current to dip at this point. Okay, it's possible, but it doesn't have to. If the grid current goes over 200 milliamps, reduce the drive at once. Unkey the exciter. So here it's a transceiver, here it's an exciter. The plate current will dip as you rotate the control. At the time that dip occurs, the grid current will go up and the output will go up. But the peak output does not necessarily occur at the dip. It may, and it may not. It doesn't matter. but you'll see the plate current dip. The grid current will go up. Here it says if the grid current goes over 200 milliamps. In the prior, where was that? Oh yeah, up here in the prior paragraph it says when the peak grid current reaches 190 milliamps, it'll go into standby. Well, so you can never get to 200 milliamps because at 190, it's going to go out of transmit. So I don't know. Probably that should be a lower number of some kind. I don't know what that would be. Reduce the drive. This is not a good way to tune up an amplifier. Observe the output on an external RF watt meter. Increase the drive till 180 mils of grid current or 750 mils. I'm sighing because it says here to put 80 watts into this thing, and I don't know that you've at this point got it properly tuned. Quickly adjust the plate in load controls. Remember that 7-second thing for maximum power output. That part's correct, but the procedure to get there is wrong. Reduce the drive until the desired output levels are obtained. Reduce the drive until the desired output levels. Okay, what are they talking about? What is the desired output level? Did they specify that? Somehow I missed that. Rotating the load control clockwise reduces grid current. Yeah, it does, for a given amount of drive. If the load control is set too low a numerical setting, well, let's just say if it's set too low, severe stress on tank components may occur. The plate current should always be peaked for maximum grid current or power output down exceed 750 milliamps during tune-up. I'm going to suggest a better way to tune this thing, and let's start with, you're going to tune the amplifier for its maximum output by putting the transceiver into the CW mode or FM mode. That produces a carrier. You don't have to worry much about RTTY. So CW or FM. And again, you're going to check to make sure that the SWR on the system is less than 2 to 1. Switch the transceiver to either CW or FM with the amplifier in standby. Put the transceiver into transmit and adjust the CW or FM for, I'd say, let's do 4 steps. So we're going to take that 80 watts divided by 4. So our first step is going to be 20 watts. So we're going to tune the amp to max out with 20 watts. So we're going to put the amplifier into the transmit mode, key the transceiver, which will key the amplifier with 20 watts of drive. Adjust the load control first for max out, and then the plate control. Load control, plate control, load control, plate control. And you're going to do that in about 5 to 7 seconds. So if you want to put the thing in transmit, rotate the load control for max out, and then unkey, stop transmitting. We're going to call it key. Then key it again, rotate the plate control for max out. Now you've done that at 20 watts. Let's do it one more time. So key it again, load control, max out, unkey, key it again, load control, plate. Now you're going to go over to the plate control, rotate that for max out. So load control first and then plate control. Now let's increase the drive. So we're at 50% drive. We're going to go to 40 watts. Put 40 watts into the linear, rotate the load control, max out, unkey. Key again, rotate the plate control, max out. Go through that one more time, load and plate. Now increase the drive to 75%, which would be about 60 watts of drive. Key the linear and the transceiver by pressing the transmit button on the transceiver. Rotate the load control for max out, unkey. Key it again, rotate the plate control, max out, unkey. Key it again, rotate the load control, unkey. Key it again, rotate the plate control. Each time you're doing that, you're rotating for max out. At this point, keep a really close watch on the grid current so that you don't go to the point where it trips. And that is 190 milliamps, which they indicate if you go over 200, In theory, you should not be able to do that because it's got a trip circuit. Now let's go to 80 watts, and we want to be really careful that we've properly tuned it at 60, we've properly tuned it at 40, we properly tuned it at 20. So let's go full bore now, 80 watts of drive, key it, rotate the load control, unkey, rotate the plate control as you key it for max out. Now just stop right here before you do anything else and key the transceiver again. And now take a look at the grid current and the plate current. Make sure that they don't exceed the values that they talk about in the instructions. So that's their 750 mils of plate current and 190 mils of grid current. You want to be below that. We're going to do one more step, actually two more steps. So we're going to do that again. We're going to do the key it, load control, unkey, key it, plate control, unkey. Each time you're tuning for max out. Now, once you've achieved that, and you may have a watt meter and you're looking at the watt meter and you see that you've got the output that's specified in the instructions, I want you to take the load control, which is the one below the band switch, and rotate it just, let's say, halfway between two numbers. So if you're at 5, go to 5.5. If you're at 5.5, go to 6, etc. So increase the load control, and as you do that, the grid current's going to go down, and the output's going to drop just a hair. And the reason for doing that is in case you inadvertently put 100 watts into this amplifier, you've tuned it for that 100 watts by rotating that knob without having to put 100 watts into it. So if you inadvertently do that, it's not going to create splatter. That's how I would recommend that you tune this amplifier. Again, the dip in plate current may or may not occur at max out, and you're going to go through 4 steps. It says 80 watts of drive. We're going to do 20 watts, 40 watts, 60 watts, 80 watts each time, rotating the load control first and then the plate control for max out. As you do this, you're going to keep one eye on the grid current and one eye on the plate current and one eye on your on your watt meter. I hope that helps and that I didn't make it more confusing, but I find that these instructions on the Ameritron amplifier are frankly, I just looked at one page, and it's very poorly written. My guess is that no one's ever proofread this thing, because if I found, I don't know, was there 10, 12, 15 mistakes on one page? Likely the whole instruction book is just full of mistakes. With the number that they've sold, I'm surprised that there are, and I think I found another mistake just looking at my monitor over there. It's a nicely designed amplifier. It's a great way to get extra output for not a lot of money. For the price point, it's with what you get in these things, it's a bargain. It's too bad the instructions are so poorly written, but hopefully what I've described to you helps just a bit. If you've enjoyed this video, please subscribe. I'm trying to build my subscriber base. If you have any questions about how to tune up an Ameritron amplifier, post it below. There are a lot of guys who watch my videos who are a lot smarter than I am and probably can offer an answer. Having a linear amplifier is a good thing as we get into these increasing sunspot solar flux numbers. There can be a lot of fun on the HF bands, especially 20, 15, and 10 as the solar flux increases. 73 for now. I'm Jim W6LG, your YouTube Elmer with Ham Radio Basics. Thanks for watching. Give me a thumbs up or a thumbs down, and we'll go from there. 73. Bye-bye.